Hi everyone! Today we're going to talk about some of our basic geometry vocabulary. Now, as we're watching the video, feel free to pause or to rewind and rewatch the video to get your notes. Let's go ahead and get started. Our first term is a line. A line is a straight, continuous arrangement of infinitely many points. It continues forever in two directions. Basically, it means a line is straight, it has an arrow on both ends, and it keeps on going. So it looks something like that. Again, doesn't matter which direction it's going in as long as it is a straight line with arrows on both ends. Now, let's take a look at what wouldn't be a line. Here, we have arrows on both ends, but it's not a straight line. It is curved, so that's not considered a line. Here, we don't have arrows, which means it doesn't keep on going, so that's not a line either. Next up, we have a line segment. It consists of two endpoints and all the points in between them. So a line segment can be part of a line, but it's not a line itself. For a segment, you might see any direction, but you have endpoints on both ends, here, and it is straight in between. Could be a different direction, that's okay. We have an endpoint, and the connecting straight line in between. So what's not a line segment? If it curves, it's not a line segment. If it keeps on going in both directions, or even in one direction, it's not a line segment. All right, here we're going to pause for just a second because it's geometry story time. All right, so we are going to take a break for a quick story, and let's take a look at what we got. Aww. Mr. Line Segment and Miss Line fell in love, got married. Yep, you guessed it, it's a love story. They got married, and they had a little baby. Aww. What did they name their precious little baby? They named it Baby Ray Ray. The end. Alright, so our purpose of our story here, a ray is the best of both worlds of a line and line segment. So a ray has part of a line that contains one endpoint and all the points to the one side of the endpoint. So instead of arrows going in both directions, the arrow only goes in one direction, and the other side has a point on the end to let you know that it stops there. Again, doesn't matter what direction, as long as there is an endpoint on one side and an arrow on the other. So what's not a ray? If it curves, it's not a ray. If it stops on both sides, not a ray. Next up, an angle. An angle is two rays that share a common endpoint. So we have two rays. Here you see our blue one and our green one, and both of them have an endpoint, and that endpoint is shared. So this makes an angle. You also see angles in things like clocks. If you look here, we have the minute hand, or the hour hand and the minute hand, and they make an angle. They share a common endpoint here at the center. So that makes an angle. Well, as part of our angle, that common endpoint, we have a name for that. That common endpoint is called the vertex. So when you have two rays forming an angle, the vertex is that shared endpoint. In our clock example, you can see that the vertex is the center of the clock where the hands meet. All right, let's keep going. Certain types of angles. A right angle is an angle that measures exactly 90 degrees. You might see a 90-degree angle as the edge of your paper, the corner of a box, anything like that that measures exactly 90 degrees. You see the right angles a lot in construction and buildings and windows. If you look at this window picture here, every pane of the window and even the edges of the window form a 90-degree angle. Now, if it's even slightly less or slightly more than 90 degrees, that doesn't count. It has to be exactly 90 to be a right angle. Be careful if it's not marked as 90 degrees, but don't assume that it's 90 just because it looks like it, because it could be one number off. We have to be very careful. All right, next up, an acute angle is anything less than 90 degrees. So if your angle measures 89.9 or 89 degrees, that's less than 90, so that's an acute angle. And the way I like to think about it is the angle itself, the space in between, is small. We think of small things being cute, like a kitten. A kitten is cute. Aw, it's a cute angle. So now keep in mind, it doesn't matter the size of the rays. The rays themselves could be pretty long. What you're looking at is the angle inside. So we see this one's definitely way less than 90, so that's an acute angle. If it is 90 degrees, it's not an acute angle, that's right. Or if it's more than 90 degrees, that's the one we're going to talk about next. More than 90 degrees is an obtuse angle. An obtuse angle measures greater than 90 degrees. Even if it's 90.1 degrees, 91 degrees, anything above 90, that's obtuse. So here, that looks like it might be a right angle, but if we measured it, it's 91 degrees. Because it's over 90 degrees, then that is an obtuse angle. Now keep in mind, we're not talking about the length of the rays, we are talking about the size of the angle in between. And here, that angle is definitely more than 90, so that's an obtuse angle. Now, if you have a right angle, 90 degrees, or one that's less than 90 degrees, those are not obtuse. All right, let's talk about congruent. When we get into more geometry lessons, we will learn that congruent doesn't necessarily apply just to shapes, but it can also apply to angles. Congruent means it's equal in measure, it's the same size, and the same shape. So for example, we have two angles here, and both of them are 40 degrees, so they measure the same. So those angles are congruent. We also have congruency in shapes. These two triangles are exactly the same size and the same shape. So those are congruent triangles. Here we have thing 1 and thing 2. They are the same size and the same shape. So those would be congruent figures. Now, if you have the same shape but not the same size, that is not congruent. A midpoint. A midpoint is the point on a line segment that divides it into two equal or congruent parts. So if we have a line segment and we have a point in the middle, to be a midpoint, you have to have the same measure on both sides. Because we have 5 centimeters on this side and 5 centimeters on that side, then this dot in the middle is our midpoint. If it is even slightly over to one side, we have 2 centimeters on this side, 2.2 on that side. That is not a midpoint because one side is bigger than the other. To bisect. To bisect, we cut in two equal parts. So we are cutting something in half. We do this a lot in the kitchen, right? Cutting vegetables in half. So to bisect something, we cut it exactly in half. So with a line segment, you would have to cut it in half through the midpoint, and either side would have to be the same measurement. On this example, we have 4 inches on both sides, so this green dotted line here is bisecting the line segment. Now, what about an angle? We can cut that in half too. If you have a dotted line in the middle of an angle and you have the same measurements on both sides, that's bisecting the angle. Here we have 20 degrees on one side and 20 degrees on the other. So this blue dotted line is bisecting that angle. If it cuts anywhere other than the exact center, one side is shorter than the other, or one side of the angle is smaller than the other, it does not bisect the angle or the segment here. All right, let's get back to lines for just a minute. All right, we have intersecting lines, lines that intersect or cross or touch at a certain point. So they intersect right here. So those are intersecting lines. To not intersect, they would have to be parallel lines. We'll talk about that here in just a second. But you see these will keep on going and they will never cross or touch. Perpendicular lines are lines that intersect and they form right angles. So not only do they intersect, but the angle in between the two form exactly a right angle, 90 degrees. So here we have an angle of exactly 90 degrees. So we would say this is perpendicular. Again, you see this a lot in construction and building. Your supports, a lot of them will have a lot of 90-degree angles when they create their building. All right, and you also see it in things like windows. If you look at the window panes here, these two panes cross and they form 90-degree angles in each corner of the window. So those would be perpendicular lines. Now, if they intersect and don't form 90 degrees, or they don't intersect at all, they cannot be perpendicular. All right, guys, we ready for our last vocabulary word? That's what I thought. All right, parallel lines. Two lines that lie in the same plane and never intersect. As far as in the same plane, we're not really going to get into that a whole lot right now, but two lines that never intersect. So they have to be parallel. That means they've got the same slope. They do not intersect at any point in time. And if they were to continue on, they would never intersect. You see parallel lines lots of places. The markings on a football field have parallel lines. So they are all parallel all the way from one end of the football field to the other. Now, if they intersect at all, they are not parallel. All right, guys, that is it for today. So thanks for joining me for Geometry Vocabulary. Have a great day.